Hello everyone, it's me Davai, and today I want to present you my new pet project just to play around, to make my own research about this beautiful thing called Noble Cryptography. Precisely these four libraries that uh, one man called Paul Miller published and maintains in a very high quality JavaScript code published transparently and in a very trustable way. All these primitives for cryptography, and they're audited and with a long history of releases and future plans. And this is very beautiful open source thing that inspires and actually powers a lot of modern infrastructure, like digital things. And um, it is open source, and what I love about it is there is like really JavaScript based. There's no place. I didn't read all this. Even it's like hard, and a lot of things are hard math. And I'm not a cryptographer in any way. So here you and me, we just trust this guy who's really cool, really interesting project. With like on different scale, and we today I want to tell you what I found and how I find it useful in my projects, because I need authentication. I need a user to have a key on my device, on their device, to encrypt their data. And what we want is to have some long passphrase that the user can put in. Yeah, it can be a short passphrase, but this was never be secure. So anyway, the like this base ground, like the good level of entropy that the user can provide, is represented by passkeys. Is web authentication, WebAuthn, and you can basically create a passkey. Let's say I'm a user, I'm a hash user, user one. Okay, user one, and then I will just use my touch ID for user one and logging in, and I'm logged in. So what happened? What is this? This is a long story, and we can just come back for a second. I can explain you what is happening. So we have cryptography based on noble curve ciphers and hashes that allows our web apps to have peer-to-peer identity. So now I can use the passkey for the user one that I've created, just only one still. I can use it, and I will log back into this cryptographic identity. So this is the generated based on the passkey, and passkey provides around 20 bytes of entropy. So it is like 20 letters basically. So to enter this securely, like browser engines provide us with 20 bytes. So you should at least provide 20 bytes of entropy. It is a good mark. You can put whatever. It can be more. Yeah, you just do, but this should be complex, not just 100 ones. Okay, because now when we press derive key, we derive this key for like around 1 second or so, maybe a little less. Uh, because there's a lot of calculations that are single, like all irreversible. So we just hash many times basically, and we get the key for this. So that time that it took to open took some memory to and computation to calculate the master key that we can reveal here. And this is the bytes of the master key. But so now we can use this master key to log in back to the same user. I can refresh. We don't have any. We have memory. Okay, we have session storage right now, and this is already a good thing. So we have this master key stored in session storage of the browser. So while this tab is open, this thing is in the session storage, and that's why when we derive, it's instant. Now we don't need to actually derive key. We just use this master key, and we calculate the identity, the public key, the encryption key, and we do this in a worker, so the UI stays responsive, and we can do very cool things with it in our web apps. It can be just a game. You can just have it, yeah, casually. It's not that serious. It's just basic clean, data handling, where you don't have all the responsibility for the user data in your application. So you can say, I want to make an app one that will be a context for this key, and now I can have a new app key that is derived. So it's like DK here, derived key, while this is MK and this is EK, and you can see that this has a pattern. What is this actually? And this is very, very interesting things, because this is the like Bitcoin technology that was evolving there with all the wallets. It's this beach batch BECH 32 encoding for bytes. It is operating on 5-bit words, and I will show you it in the code soon, but now I want to explain that it is like a prefix, then the one, there's a separator, then it is like the message, basically kind of like this, and there's like a small checksum for the message that is appended here. So it is the structure, and it is very efficient for transferring like keys. This is how 32 bytes of entropy look like, and this is pretty much, it's like a one sentence kind of thing, or like you can really tell this. So the batch in hashing is very efficient in like there are no duplicate, and if there are duplicate, you can tell it as a 1, you can tell it as a L, you can tell it as a I. It will be working in the same way, and you can capitalize it, you can make it lowercase. It's working, and yeah, the checksum can provide some error detection, and it's not like super efficient for bigger loads, but still it is a very interesting format because it's readable. You can say HDI D1RQ04 PTPZZ PXZA to it's like stream of content. You don't need to have like slash to the left. For base 64 it's not working. 32 works well, and I like this. You can send this in a messenger. It's like looks content like. Okay, and what it is, so identity hash is basically just a hash of this public key, and public key is calculated from this master key. So this is your private key, this is your public key for signing, and this is a public key for encryption. So someone can use this public key to encrypt for you. And yeah, let's go into UI first, and then I will explain this in code. So now we can, and also these keys we can use in our apps in the same way. So if you understand how HashKeys work and how Noble Cryptography works, you will make all of these work in your application easily. So now we have this sign verify. So this is a message that we are signing here. And when we sign a message, we have the signature and a public key that we are using. It should be, it should be this same key here. And it is 343. Public key 343 and 9, and the signature. And now it is pre-populated here, so we have the same message, the same signature and public key, and when verify, yeah, it is verified. So for this, we need this private key to sign it. We don't need only the public, we need the private key. So only you knowing this key will be able to sign this message. And this is verifiable by anyone. So for this, you don't need to be signed. You can verify anytime, any message just by taking a signature, public key, and the message. Yeah, it is for consistency and for validation of input that is like untempered, and you can trust this data, being it encrypted or not, because you can encrypt, of course, you can encrypt, and all this happens in the worker, so it can be a tricky thing for a computer, but not for UI. So, but anyway, these ciphers are very fast, and if your payload is small, you just get this. So you just get two of these hashes, two of these numbers, and this is like ciphertext CT, and this is like nonce. So this is a random number that you have to use with the actual master key to produce this cipher, and it will be every time new. We will like never repeat this nonce. If we repeat it any once and someone sees that, they will get your key. So this is where I need to make more research, because encryption and decryption in this like nonce is kind of makes it everything complicated. But we can of course just append it here, just connect, just then and use it as a one string with this uh, nonce like appended to the to the last bit, so you can just cut it right there. Yeah, it is a field of research, but anyway, we encrypt and then we decrypt the data because we know the master key, and we just have the nonce, and we just apply this to cipher and decrypt it, and it's pretty fast. uh, yeah, even for big payloads, so because it's very efficient code working in a worker. And the last thing that I want to show you is that you can spawn another user, another identity. Like you can make them any number of them, and they will have a separate worker instance, but basically the same code. So it's very lightweight way to have those identities spawned for you, and then you can use them to, of course, sign messages. For example, if this is like an agent or something, it can sign messages on its own, so you can validate that all those messages are coming from the like probably decentralized sensor or anything like using your browser or whatever. It is your thing to explore as a developer. I want to provide you with my ideas as a library developer, and just explore of these like fantastic noble curves and hashes, because now we're using the actual elliptic cryptography. So it is public key and private key, and we have all of these. So we use this encryption key to encrypt to Alice. So we use the key of Alice, and we encrypt it, and now only Alice can decrypt it, this message with her private key. So this is the base for secure communication, and again, Alice does the same on her end, uses my public encryption key, this EK, to encrypt a message for me, and then I decrypt it here. Yeah, this is quite simple thing, and I think it's simple for me because I'm so many years in this field and still struggling to comprehend many of these concepts and ideas. But anyway, I want to just share what I have for now, and you will just have this information and do whatever you want with it. It's just open source. So what I'm like my point of view is I use Vue. I'm developing web apps that are just working as a single file HTML, so they work strictly in the browser. You don't need any servers, and this is So this is a browser package that is installable in your JavaScript project, Node, on your npm, pnpm, yarn, any build system, and you can have it just in your package JSON, and then you will import this single function, useAuth, that will provide you with an object uh, with a optional namespace if you want to change it for your application, and then you log in. This is the idea of how I constructed this. So maybe we could log in at this moment, but it's good to have the auth that you can just stable auth that you can log in and out with different passkeys and passphrases, and this can be sequential, so you can reuse the same established auth. Or you can do whatever, it's quite easy to use. So then this auth has methods and has some of the properties that are useful for developers. So I will show you how to just sign. So you have sign a message and verify a message with a signature and a public key, and you just await this. So these are asynchronous. Because they're running in a web worker, and we just talk to these web workers and receive messages from them, and we have to wait for them. But internally, and this is beautifully sync. You will see it. So encrypt and decrypt also works. If you have just a secret, you can just encrypt your own data. Um, so you just provide the data, and you get this package that you can store, you can do whatever with it, and just have fun. Actually, it's a cool idea. If it is, for example, like a big thing, you can have this stored in like a blob storage, and this can be stored in metadata storage. So this is like completely secure. Yes, you can just be laughing. When someone will tell you that any kind of computer will ever decrypt this like easily. No. So and then peer-to-peer. This again, it is just elliptic cryptography, and but it is like simplified, but preserving these names so you don't lose yourself in this, and it is just public keys, and this is the interface, and documentation is not there yet. There is, of course, the npm library description, and you can study this as you, as you will see. We have some downloads already, but it's very new. I just published it, and just got the new domain from js.org. Thank you guys, big respect for this. Like, you can acquire I can acquire this namespace and get there a little bit like 3 domains to have this beautiful projects. So here it is, like an example of a code, how you can run it. And it's not super profound, but you can read all of these signatures for the functions, and just I try to keep it all completely in sync with code, with LLMs. So some things can go wrong maybe in these descriptions, but there are most of the ideas of the system. So for example, batch 32 prefixes is like this encodings, and we have HK by default, but you can set it to whatever 2 letters. Lowercase is the limit. We don't want to mess with this. It would be too hard to manage after if we have these like different, but because these second ones will go for the type of the key or data that is there, so it is easier to understand what particular bytes you're holding. This, it would be like application and then purpose, and it is, you can debug easily like what is going where. It's much better to handle this information like even being not public, not visible to user, but even internally, I'm providing the data for from a WebAuthn, from Passkeys. They are provided as a string formatted into batch 32. It's cool to have it. It's consistent, and yeah, why not? It's not that hard to calculate. It's just easy to maintain. And also we have this session persistence, yes. So we store it in a session storage, and if you log out, we remove the master key from the from there. And yeah, we could even make this, if we don't include the storage, and we can even never have to have the method to get the master key, because master key can just persist. We can every time like calculate it from our passphrase or passkey, but yeah, it is needed for persistence, because yeah, storing the passkey or storing the passphrase openly in even in session storage isn't, I don't think it's a good idea. But maybe I'm wrong. Maybe it is better to persist. Just maybe take the bytes of. Yeah, I will think about persistence any once again, because really master key should be inside the auth. So you shouldn't be extracting your master key for just any purpose. You should derive keys, and yeah, this is where the security comes from. If you use just the master keys, and you lose a lot of security from the script key derivation function that is used here. So I hope you're not too bored, but now you already see the code, and you can understand that we're going deeper into the code itself, and how it is organized, and how you can use it just in a single HTML file. So if you just use this, you can already kind of log in and have your identity generated in just this size of HTML. It's in test folder in public, so we can just probably find it here. Yeah, it is here. So if we just why is there some error? Maybe I didn't test it like thoroughly. Nothing is happening in particular in console. Okay, maybe I just forgot to fix something in development. It's, yeah. Anyway, it is a working thing here. Yeah, so it is also available, of course, on GitHub, and you can put a star on it. You can see all the releases with versions, and you can try all the releases if you want. Documentation and the code, yeah, which is quite lightweight. It's JavaScript, Vue, and a little bit of HTML. I tried to be brief and short about the code itself, but let's go look at it. So what is the main thing is that we have the app build. So this is one single file, HTML file, that is published here, and it is built with Vite config.js, and it is built into dist folder, and you can see that here we have all the assets. That's strangely maybe a little bit not fixed thing. Yeah, yes, it's not updated. Yeah, I need to update it to new interface. Basically what it takes is to have it like this: input use auth, and then we say const auth is use auth, like this. And now it should work if we open it. Oh, yeah, we have the MK. So we know that for ASDF we will derive this key and it will be QR PK. Okay, and now we can go here and basically just take ASDF, okay, and have it here. ASDF, derive a key, and it will be here. It is different, right? Yeah, it is different. Because it's different salt, yeah, and we're using different salt. Probably yes. Different prefix at least. So, but we can use the key itself. So we can maybe derive, but yeah, when we go here, we will see that we can log in and with this key, and it will be the key itself. No. Yeah, when different app key will derive. Yeah, we're only using compatible keys. Okay, but I will maybe change this later. Okay. Anyway, let's go to the code again, and yeah, let's look at code more deeply. So this is the build itself. It's nothing too special. It is Vite build. It has Vue. It has CSS for utility classes. It has Pug for convenience of templating, a little bit of presets for CSS, and the config that uses all the plugins, and we have this single file that builds everything together in one single HTML. And also we add this custom script that adds some statistics just for me to see if anyone is ever looking at this, and also just this registered service worker that's happening when we are in the build. So in development we don't have to have all these service workers stale in the browser, and that's where it's built, and this is the format for workers, so it is all packed neatly together in a single HTML. And when we hit build, it just builds, and we can see that it is just a little bit less than 200 kilobytes, and it's already including all the power of cryptography in it, so you can just have the actual application you can create on top of it can be like 300 kilobytes. Okay, so it is efficient, and let's see what happens. We take this HTML that has the manifest, so we will have this manifest here, and it is going to make this installable PWA. Also, the meta goes just for search engines, for social media, for just yourself and your like browsers that consume all this data. And for PWAs, again, we have this background colors set, and then there is this app.js that is just the only thing that handles what happens in just this only one div. Yeah, it is an SPA. It's not a big thing because yeah, we still have very interactive UI, and it is highly private. We never ever like leak any data of this, so it's good to have this one place to handle things around. Yeah, so we go deeper into the app.js, and we see that this is a Vue app that has a Vapor interrupt, but I didn't have good results with this app. But sometimes now it's still alpha or beta, but yeah, Vapor is a cool thing. It's coming. But yeah, we just have CSS and mount this to this Vue's SFC, and this is the single one SFC that we use to have the whole application with the scripts and also template that is written in Pug and CSS. So here you can see the main page with all the descriptions and npm and default the GitHub. And here, yeah, basically this code is right here. You can see it here. So I find it brief. I find it very readable and cool to have these classes, especially with all the colors here and uh, um, icons. If you need, they are also highlighted here. And yeah, it's very readable, and I like this code style. If you don't like, it's easily convertible back to HTML. But yeah, it is what I have here in my applications. But let's see what's the code itself. We're just basically using this same single function, useAuth. And we just established that useAuth is HD, this namespace, and that's why we're not like compatible with that one. But still we can have the same keys. We can just use the default. It's not a bad thing, HK. So, and Alice will log in later. So when you log in, you're actually establishing your identity. So now it's just a container. And yeah, we have all the state management and everything made in functions, readable, and with error handling. That is just handling this beautiful useAuth library. So what we provide is this useAuth composable that is providing us with reactive state. So this changes whenever we log in or auth, log in, log out, all the state just instantly changes and it gets updated. And also worker is updated. So yeah, it's very robust. You can reuse this instance, but you can use as many instances as you want also. So you provide the prefix. We normalize it hardly in a hard way. So yeah, just stay safe. Maybe it's too much, yeah, but yeah, we have this super reliably 2 letters of prefix that we use to send init just when you run useAuth. But mainly we need to establish the worker. So this is the where I want to like emphasize that it is very important to have all the cryptography and key derivation happening in the worker, because it doesn't freeze your UIs, and also it's more secure because memory is in that another thread accessible via like already predefined code that is basically imported as a string, and you just pass a string here like in a worker constructor. So it is highly efficiently built in. You can see it in the code itself. You scroll down and at some point you just find, yeah, this string. Oh yeah, it's the end of this string. So yes, this string ends here, and we start working with Vue and stuff here with template, but all of this is a string that is the whole worker like embedded, and it's very efficient way because we really can have this multi-threaded operations just in very easy and robust way. But of course it takes some pressure. We need to work with some kind of API, some kind of messaging system to communicate with it. And here we solve it with very elegant small helper that is just sending messages and having this map of pending messages that then on receiving from worker message we get to this pending and resolve it. So we take this resolve and store it until we need it, and this is very beautiful, short, without any complexity. And my goal was to keep it very short, and I think I'm kind of succeeded in that. It's no TypeScript, no bloat, no like complex state management and wrappers. It is just one reactive object. That is basically it. We can just look what else we have, and then we can have a look at the whole auth object. So here, yeah, we have this message handling, because we have the ID message ID for any message incoming, and we're replying with the same. So we can just um, react to things here. We react basically to authentication, if it's true or not, if we have something or not. And also we can go to resolve this pending thing. On error, we just say that's an error, and we watch authenticated and store the session storage. So this is the only watch we have. We just store our master key in the session storage. Yeah, it's quite secure, because yeah, this is the only it's only a session, but still, yeah, can be improved. I'm open to any, of course, improvements. Yeah, so for okay, yeah, and let's see, we import just batch for of course hash this is for passkeys. We will encode passkey entropy, and we get entropy from the use passkeys, those two simple functions. You can just open them, copy paste them. These are working. I enjoy them because they just give you the raw ID, and that's what you actually need in this peer-to-peer environment. That's only thing you need from the passkey. Give me the raw ID, I will do whatever I want with that. So it is like a signature from this private key that browser never gives you, but this is a cool thing. Okay, it is secure. The user can be sure that, yeah, they produce secure keys. So yeah, here we go. That's it. We just return the auth object. So the auth object is the only thing we have, and this is the state and also the methods. That's it. Yeah, it can be better, it can be optimized, and it maybe can be more consistent. But basically, yeah, you can passkey auth, and we just wrap around that function, and also yeah, basically login. So we send we use the login function here, and login is already a send. So we are sending. So still, again, we will go to login. So login is the main thing, the entrance, and we just have the password, and we send and command of auth to the worker with the password, and it will reply and resolve. And where we have this call, we will finally, so it will kind of boom 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 fall back here into this. So on this login, you will receive the answer from the worker, the reply. That's where transferring the actual like bytes, but in batch already 32. On logout, we get out of the state, and the state is all basically here, and also, yeah, it is all there. Let's see where the master key goes, right? We don't have any persistence of any kind of key here, only public things that are, and the key is already in the worker, and we ask it to do things for us. So we have the state is updated, and stay is updated. After we log in, the state changes to authenticated, gets true, and all these things become filled up. Because the auth is a good answer when we receive the auth answer. But for signing, it's just you send a message and you receive the signature and the public key, and this interface kind of works for all these systems. We have some sensible defaults that are working for the app without specifying them, but basically it's just a wrapper around the worker with these only like main thread special functions like recall. So we go to the session storage and recall everything back. And that's it. So we just have this function. We need to run it again on like mount or something after we refresh the page, and we can have the same key back coming. Yeah. So here we have legacy. Yeah, it's just nothing special. We can take even less care about these prefixes, but yeah. It's still very short code. It's less than 200 lines, and yeah, the main thing, of course, is in the worker. But it's still also not too long. It's just 400 lines, and I'm not going too deep with this, but here where we have this foundational layer, and it is so we have all these noble curves and hash, basically noble hashes here only, uh, that are we have them inside the worker, and ciphers, yeah, and cryptography, all of this. We have this in the worker, so we don't have this in a main thread. It's much safer for us to do this. So app prefix management, the salt changes become, yes, depending on the app prefix. So it is another layer of security. So rainbow attacks are less possible with this prefix thing. It is, I think, one of the beauties of my solutions, but yeah, they're open source. Do whatever. I want just this level of security in our web apps, and let's do it in best way. So object freeze is just an important thing. We will have all these like prefixes here, so we never modify this, and yeah, we go with this tags, tag mk, tag pk, and we never use strings here again in the code, but it is still safe. For this, we also should maybe make a freeze, but okay. For now, contexts are these like three. And a crypto state. So basically, the worker has the real state that is like the primary state that is shared with us with the messaging, because the worker has the master key that is calculating itself. And it's so if you want the master key, you need to calculate it, and yeah, worker is there. Then we have some helpers for bitch and. Um, and here is the key derivation, but it's just for master key. So when we have the master key, this is a lightweight way to calculate a derive a key from it. And yeah, possibly I will change this algorithm, and yeah, we will upgrade this. And this is a subject for upgrade, because really I'm not that deep into cryptography that I can be on any kind of authority here. I'm just learning. This is my like study project. I just want to explore things hands-on, and yeah, doing this with the browser, it's super fun. But I kind of understand what's happening here, and I get I know that I have the idea of elliptic cryptography, and how we get this public key from the signing key that we have established from the material, and material is derived from our master key with the context signing. So anyway, it is a task to derive this key. Like you have to know many things to derive this, and then we get the public key from it. So this kind of escalates, and it escalates. Yeah, we have the identity. It's also SHA-256, quite compatible. I'm not sure, yeah, if it is insecure, if it's broken. I don't think it's like a dangerous place to use it in a way here, but yeah, we can use Blake or Blake 3 or something even better. Um, Please suggest if you know. So manage the handlers messages, yeah, and we have the handlers object, and this object is the core. I also tried to make it super readable, so this is the only object we have here. So half of the code is one object, but this is like a collection of methods. So you just can collapse all the methods and see that those methods are exactly the messages that we can send to the worker. So there is no like layer of this list. We just directly send data received from the main thread to like this same named function, so one to one. And only need, basically we just set only the salt and a prefix. You can do it at any time. You can even not do it. It's not a big deal. You don't need to run this in it. We just run it internally once, and yeah, we could even just yeah we need this moment to run. Then auth. So this is where we have the data that is actually the password or the passphrase, and we try it with a batch. If it's batch, we use it as a master key. If it's not, then we where's it? Yeah, here with Scrypt we derive this key with Scrypt with quite a secure values. We can bump these numbers and make it even more secure. Now I was just testing, and if we bump it just a little bit to just 19, it will grow the load will grow substantially, and this is where we control the security of our generated master keys from the input. But especially the fact that we use salt app salt, and every app developer will use their own prefixes. This is very secure, even at these values. But yeah, we can work on this. This can be an actual parameter that you can set, but I want to make it short and readable, and this is where I think I succeeded, because yeah, we just have this fantastic initialize crypto keys function helper that I've shown you, and we really populate the crypto state from there. And then we reply. So we have success, and this is the object that we reply, and we just apply this object to the state. So this is the synchronization of state to the view, just to the UI, because it's just there. You can just have it right there in UI. You can just say that if authenticated, and this authenticated stays in sync with that authenticated here, and here of course. So we will say authenticated false, and we will react to it in the main thread. So get public key sends the public key to the consumer, get master key also sends this with the batch. So batch is just the way to export things. So we use batch on the in the worker to send. So we send strings, not bytes. It could be controversial to use strings, not bytes, because bytes are more efficient to send, but it is more reliable in case you would want to use the worker directly. It's easy to work with this worker directly without my Vue wrapper, and then you will just have the same result. You will have strings easy to work with, because you can just plug them into all of these, but you can persist them in any kind of storage, not thinking about conversion and how to store bytes in JSON or something. Just have the strings, 3 strings, and you just verify it, and all like strings only with some kind of validation and some kind of error detection. So plus plus win-win situation. Yeah, and here we go. We encrypt data with elliptic curves, and this is cha-cha poly, very nice asymmetric encryption going on here if you prefer to go with a public key cryptography, if you will go with a public key and a curve. If you're not, if you just want this cha-cha with data with no public key, then you will get encrypt. So this is a complex encryption function that combines everything to just have one function to run everything. Maybe it's not the best decision. Maybe we can just have these like encrypt symmetric, encrypt asymmetric. Of course, it is just a very fresh new function and library overall. uh, it can be optimized in many ways, but my goal is to be short and readable. And even here I can see that this is not so readable, or maybe it's readable, okay, but yeah, this validation, yeah, we can do better. But anyway, it's working. It has all these complexities that I barely understand, and I don't want to like go too deep into this, because like I'm trying to um, keep this as readable as possible. So now you can use even like just have these 400 lines, feed them into an LLM and ask it if it's secure and used properly, because my guarantee is that it works. If there is something that is like broken from conceptual level, I never intended to do this, we can fix that. And of course, you can abuse this is a bad thing, but I hope we have more good actors than bad actors. And yeah, this is just an open source thing. Everyone can just copy this, modify, and make it better. Uh, just not don't forget about the license, okay, and copyright. But it's not it's just a thin layer around the best thing, the one of the greatest like libraries I've ever seen in JavaScript, and it is Noble Cryptography. Really, this is beautiful. This is cool. So many people are already using it. Not many people are talking about this. I didn't find any videos that are explaining how to use those noble curves. And even this video doesn't explain you like the depth of it, but because I think this function is messy, it doesn't like explain everything in clear way. Mm, but basically, yeah, we have three types of uh, encryption and decryption combined in one way. No, two types. Yeah, if else. Yeah, three types. So we can have the public key, and if we have the public key, then we decode it from batch. Then we have um, we get shared secret for it, and then we get the decryption key by hashing the shared secret, but that we get from our private key and sender bytes. Yeah, we have the shared secret, and then we use this to decrypt, yeah, encrypted bytes with this key nonce that we receive. And yeah, so it is readable. I will make it more readable. I will try to, yeah, but even now, so derive key is if we don't set this for cha-cha, we want to just go with uh, if we don't have a public key, then we don't need to make any shared secret. We just derive a key for encryption, and yeah, just decrypt with it. So key derivation is simple. We again use this derive key function, that is HKDF. So yeah, it's quite simplistic. I think it can be much more complex, and it can grow into like, I don't know, 800 lines, something like this, but I want to keep it short. And maybe, yeah, if we just start moving these methods out as like separate modules when they get complex. So for example, if this encrypt is quite complex, encrypt decrypt even, we can just take this module out and then just assemble all of this in this main JS file, so it stays readable. Yeah, stay tuned for this because it's just a work in progress. Now it's called like 0.2 version after some of recent updates. I think there will be more updates, especially on hashing algorithms, curves, and don't rely on this in production for now. But you can just wrap your head around batch 32. You can wrap your head around how to use passkeys in this environment and workers. And yeah, let's make web secure and fun for people to go around with all these like agentic hacking machines and yeah, generated content and everything. We need signatures, we need encryption, we need peer-to-peer encryption. We need more of this. So let's derive our own keys and store them securely and find ways to share this with users and yeah, let them enjoy privacy and yeah, future-proof cryptography in their simple, easy to use PWAs installed on their own devices. Yeah, so stay tuned with me, Davai, and yeah, put a star on my repository, use the library, and share your thoughts and ideas on GitHub and in anywhere you can find me in network. Okay, stay tuned. Bye.